what I'd like to do next is to go through a small example in the C target in Lingua Franca that I think illustrates a number of the key points and in fact might help to address some of the questions that have come up. So let me share my screen, and here we go. Okay. So here we have epoch, a fairly blank epoch screen, and I'm going to create a new project. I just go File, New, Lingua Franca project, and I'm going to call this project. I can give it any name I like, but let's just call it tutorial, since that's what we're doing here. And I will just leave the default location. It's worth noting where it's going to put this project, because that's where all the generated code is going to go. So it's worth paying some attention to that. And I'm going to pick one of the project templates, which is this Reflex game template. Now, this Reflex game is a simple example that comes from it actually is originally something created by Gerard Berry, who was at INRIA at the time and was the developer of the Estrel language. And he used this Reflex game example many times to illustrate the properties of Estrel, which is an extremely interesting synchronous language. So this project got created, and I want to emphasize again that the sort of in Epoch, the project structure is fairly straightforward. You have a bin directory, which is where the generated binaries go. You have a source directory, which is where the Lingua Franca sources go and any other associated sources. And then you have the source gen directory, which is where the generated code goes. So you can go and peruse the Reflex game C generated C code if you like. Okay, so let's have a look at the Lingua Franca code. So this is an example that you can find. It's actually in the repo in the examples directory. And it's a fairly straightforward application, but it illustrates quite a number of the features of the language. So let me first start by just running the program so that you can understand what it does. So using this terminal, I have to, let's see, I have to try to remember where the project was put. So I think runtime eclipse.x text tutorial, probably, right? That looks right. Let's just check. So the bin directory has an executable that was created at 7:35 a.m. That's 2 minutes ago. Okay, that's California time. Okay, so this is in fact what was just created when I created the project. So if I execute this binary, okay, what the Reflex game does is it simply prints some instructions. So it says watch for a prompt, then hit return or enter, and type Control D to quit. So it said, it gave me a prompt, hit return or enter. So I'm supposed to, as quickly as I can, hit return. Now, that wasn't very quick. That was 8 milliseconds reflex time. That's pretty bad. Let's see the next one. Okay, 1.3 milliseconds. I can do better than that. Come on, come on, come on. Give me a prompt. Give me a prompt. Half a second. Okay. I could try anticipating, but if I hit return when I haven't been prompted, it detects that and tells me that I've cheated, and it exits the program and reports my average response time, which was pretty pathetic. So, okay, so let's have a look at how this program works. So there's a number of features. One is that, first of all, it's responding asynchronously to external events, right? It's that's a key feature. And similar to that feature has been shown in several of the examples that you've seen so far. The snake game was responding to arrow presses on the keyboard. The web server was responding to incoming HTTP requests. These are all asynchronous events that get injected into the Lingua Franca program. And Lingua Franca then kind of takes over the processing of those events. And let me show you how that works. So let's actually, there's another thing, which is the generating of the prompts. So let me start actually with the generating of the prompts, because that shows a slightly simpler timing issue. So we have this random source reactor, and its documentation says it produces a counting sequence at random times with minimum and maximum time between outputs specified as parameters. Okay, so we have this reactor random source. It has two parameters, min time and max time. And these are set by default to 2 seconds and 8 seconds. So the time between prompts will be somewhere between 2 and 8 seconds. Now, here I show a feature of Lingua Franca, which is that you can include right directly into your source code a preamble, which is just arbitrary C code put into these brackets. And that can import other external C files, or it can define functions that you're going to use. So in this case, it defines a function that generates a random number and turns it into a time interval between the minimum and the maximum times. Okay, so it takes minimum and maximum times as arguments. So this is just an ordinary C function. So this random source has an input port, which is used to trigger a random wait. Okay, it's gonna, when it receives an input, it will then wait a random amount of time and then produce an output. Okay, it also has a state variable that it uses to count, and it has a reaction. Let's look at the details here. This symbol right here, it represents the startup event, and this chevron is the reaction to startup, and it declares that one of its effects is this so-called logical action. Okay, so the logical action is the way under program control that you request for something to happen in the future. Okay, this logical action has a minimum delay given by this parameter, which is set for this instance to 2 seconds. So this logical action will, when scheduled, so here in reaction to startup, I call schedule. So this is a built-in Lingua Franca function. This is the way that you request for things to happen on the logical timeline in Lingua Franca. So this says schedule the logical action named prompt for this amount of time in the future. Okay, now what does this amount of time in the future mean? Every reaction, the body of the reaction executes logically instantaneously. It's invoked at a logical time. This particular reaction will be invoked at the startup time. Okay, and time does not elapse during the execution. So the additional time that is specified here is over and above that logical time point, the startup time. Okay, so that's very precise, and any two requests for a timed action in the future that happen to result in the same logical time will be logically simultaneous. There's no non-determinism in the ordering of those events. Okay, the logical time at which they occur determines their logical simultaneity. It's an extremely important feature of Lingua Franca, and it's a big part of what gives it its deterministic concurrency. So I've got this logical action named prompt. Now, I've scheduled it to occur sometime in the future. This second reaction is triggered by prompt and will produce an output out. So this reaction will be invoked at a logical time in the future, and it simply prints out the prompt, okay, giving me an index. You notice on the terminal, it was counting 1, 2, 3, 4, the number of times that this has occurred. Okay. And then finally, there's a reaction to another. When it receives another input, it's simply called schedule again with a new random time. Okay, so this is program control over timing. What about external events? Well, we can look at this get user input reactor. And again, it has a reaction to startup. Okay. here's the reaction to startup. But now the effect of this reaction to startup is a physical action rather than a logical action. Okay. Now, what this declares is that a physical action is something that will be caused by some external event. Okay. And when that external event occurs, a call to schedule will be made. And at that point, the logical time will be assigned to that event based on the local real-time clock. Okay, so let's look at how that works. So in particular, in the preamble here, there is a function defined that at the time of startup, I create a thread that simply executes that function and passes to it this physical action. Okay, so let's look at what that thread does. What that thread does is just go into an infinite loop and use this built-in C function getChar to read from the keyboard, checks to see if I've hit a control D, okay? And if so, it simply exits the thread. But if I've hit anything but a control D, then it simply passes that character to this user response. And what's going to happen now is that a logical time will be assigned to this based on the physical time at which that occurs. Reaction 3 then will react to that physical event now at the logical time that was assigned when that external event occurred. And the first thing it does is check to see if I cheated. Okay, has the program actually issued a prompt or not? And if it hasn't issued a prompt, then it declares that that you cheated and it requests a stop. Otherwise, it simply calculates the elapsed time. And this is a time between the logical time at which the prompt was issued and the logical time assigned to this physical action. So it calculates the response time, increments the count, and then requests another prompt by producing an output, another. Okay. And then there's this reaction to the prompt, which simply records the prompt time. So that's how it's going to measure the elapsed reaction time, is it simply records the prompt time. And then finally, this symbol is a shutdown event. And so there's a reaction to program shutdown that reports the average response time. Okay. So that's all there is to this program. And I'd like to show you a couple of other features. Notice that there's a cycle in this program. Okay. Cycles are generally not a problem in Lingua Franca, but there's a little bit of a subtlety, right? If I go to the random source, and let me make a change in this program, a very seemingly innocuous change. I'm going to take this reaction and simply put it in a different order. This creates a causality loop. Okay, what's the reason for that? Well, every reaction of a reactor, this random source reactor has 3 reactions. Okay, these are mutually atomic. They share state, and so if one is executing, the other cannot execute until the one completes. Each execution occurs logically instantaneously at a logical time. It's possible for 2 reactions to be invoked at the same logical time. They have to have a well-defined order in order to have a deterministic behavior. So the order in which reactions are invoked at the same logical time is simply determined by the order in which they're specified. So if these 2 reactions are both enabled at the same logical time, 2 and 3, okay, then reaction 2 must be invoked before reaction 3. Similarly, in get user input, if reaction 2 and reaction 3 are invoked at the same logical time, then 2 must be invoked before 3. So that means that if 2 is enabled here, you must have a prompt at the logical time, which must have been produced by this at that logical time. And if another is going to produce an output at that logical time. It has to do so before this reaction can be triggered. And consequently, we have a causality loop, and there's no way to satisfy those ordering constraints. Okay, so the Lingua Franca code generator rejects this program and says, I cannot give you the Lingua Franca semantics with this program as specified. Simply changing the order of these reactions corrects that causality loop. So we discovered by experience that having this visualization of the causality loops is extremely helpful, because it's often quite difficult to actually be able to tell which of the what the source of the causality loop is. Okay, so this illustrates the difference between physical and logical time. Let me stop sharing. And the next thing that I would like to do is reintroduce Stephen Wong, who is undergraduate at Berkeley. And again, he joined our group 2 or 3 weeks ago and started working on this, and quickly picked up on this Reflex game and created a version in Python with a much nicer user interface. So Stephen, you want to show us that version?
Sure. I'm going to share my screen. So as I mentioned, Reflex game really demonstrates some of the key strengths of or the functionalities of Lingua Franca. And the Reflex game demo that I built in terms of logic is very similar to the one that Edward showed you. But instead, I used the Pygame library in Python to incorporate a much nicer user interface. So similarly, on my terminal, I'm in the Reflex game directory, and I can use LFC to build the Reflex game. And as it's building, I can explain how the Reflex game demo works. So when I run the code, it first starts with the GUI. Once the GUI started up, it would notify other components to listen for user input, as well as update the graphics. And whenever there's a new event generated by random source, it'll tell the update graphics reactor to update the GUI, and then so on and so forth. So let me try to run that. So here's the Reflex game. When we run the Reflex game, it first shows the introductory prompt. It tells you how to stop the program, how to begin the program. And it says press any key to begin. So if I press, let's say, a key on my keyboard, it'll tell me to wait for the prompt. And then once the prompt is ready, it'll ask me to press any key, change the color. When I press the key again, it records my response time, which is really slow. And then a second prompt will come out. And then if I press a key before the prompt, it'll show the same error message as in Atlas demo, which is you see that, and then it'll also show you my average response time. So the purpose of this demo is to show that with the Python target, you can easily integrate, sorry about that, you can integrate other existing libraries into your Lingua Franca program quite easily. In fact, this demo only took me about perhaps 3 or within the day to write. And I just ran the project for 2 weeks, as I mentioned. So Lingua Franca is really easy to use. All right. That's all my demo. Thank you.
Thanks, Stephen. Next, I would like to reintroduce Sarush Bateni, who is also the author of the Python target. But he's going to show you, so he's from UT Dallas again, working with Kong Liu. And Sarush is going to show you an application in Lingua Franca that really depends quite heavily on being able to do things in real time. Sarush, take it away.
Okay, so I'm going to talk about another fun demo that I would encourage you to try. if you're using a Linux machine or a Mac OS machine, the Windows version of this demo is in the works. So please come back in a few weeks and we'll have that. But in the meantime, if you have a Linux or Mac OS machine, you can get the tarball for this rhythm example from this link, which is rhythm.lf-lang.org. We also have this example on our repo if you want to try that later. So I'm gonna go through the steps. So I'm just going to download this here to my machine. So it was downloaded here. Whoops, I need to. Okay, so in my downloads folder, here is the rhythm example. Let's put it in a nice place. Let's just put it on the desktop. And so I'm just gonna untar this. And here is the rhythm example and the supporting files. So the way that I will use this example is in the epoch ID that I've downloaded from our nightly build. I will just create file, new project. Just a simple project is fine. And I'll just call it rhythm. And instead of using default location, I will click browse and go to my downloads folder, desktop folder. That's where I put it. And just click on this rhythm and open it up. So now I have my rhythm example. Here is the .lf file. Okay, it just asked me if I wanted to convert this to an xtext project. Just if you see that, click yes. And here it is. I have the rhythm, and I can see that the epoch ID has automatically built binaries for the examples in this tarball already for me. But I think all we need to do now is just to run the example. So here's a terminal that I've opened, and I put the example in our desktop rhythm. Okay. And if LSA is easier on the eyes. Okay, so here's the bin directory that contains the executables for all my examples. So all I need to do is do bin rhythm. So I'm going to share my computer sound so that you can hear this example. So let's just try it. And when you run it, you immediately see that on the right, you're getting these dots and some exclamation points. And each one of these dots is representing time passing. So as the name might give it away, this is a rhythm-based example which produces sounds with rhythms. And the default rhythm is downbeat. So you see this exclamation point, that's when the downbeat is played. And the downbeat is a 16th note, which is a musical term for a very short sound or a note that you can play. So what I can do is I can choose one of the instruments here. For example, I can choose clave. And you should be able to hear the clave sound on the downbeat. I can use different rhythms. For example, I can use a merengue rhythm. Or a samba rhythm. Notice that I changed the rhythm to samba, but it wasn't changed until the next downbeat. And that's a feature that I will demonstrate. The other thing that I can do is I just muted the sound. So I can actually control the tempo of the rhythm by plus and minus. So I'm gonna turn back on the sound, and then I'm just gonna increase the tempo, and watch here. So that's one of the other features of this example. So going back to the code to just talk about it a little bit. So this example was written by Edward, and it's pretty cool. So it really has two reactors. One of them, which is relatively simple, is this play waveform, which is defined in this play waveform.lf file. And this is a simple reactor which has a list of audio samples. And what you can do is you can pass an index to this waveform port. And if you pass it index 0, it will, the next time you will give it a note, it will play a bass drum, and so on. And the brain of the operation is this rhythm source. And the interesting thing about this rhythm source is it uses both a physical action and a logical action. So let me make this graph bigger. So it uses physical action to process the keyboard inputs. And for that, we have actually a library called Sensor Simulator, which ships with our jar file and with our IDE. And you can just use it in your application by using this path, which is a library path. And what you can do is you can register a physical action with this sensor simulator. And then every time a keyboard is pressed, this library will automatically trigger that physical action. And the reaction to that physical action is responsible for taking the value, which is what key was pressed, and then do whatever it wants. For example, here, change rhythm and so on. And it also uses a logical action to control the tempo. The reason that it's not using a timer and it's using a logical action, similar to previous examples like the snake example, is because you can make the tempo faster. So by default, this logical action will be regularly scheduled every 200 milliseconds. That is the default size, the default length of a 16th note, which is a parameter of this rhythm source. But if you increase the tempo, then this time will get shorter. Yeah, so one last thing that I wanted to do was I wanted to demonstrate a very cool feature of Lingua Franca, which is, again, a deadline. So what I can do is I can create a reaction to tick, and I can put a deadline on it. And I can put a deadline of 250 milliseconds, which is a little bit larger than a 16th note. And what happens is I can print here that a deadline has been missed. And you can see the graph is updated with my deadline. And if I run the example again, so I will not turn on the sound, but you can see that now occasionally I'll get this. So not every time, but occasionally the deadline has been missed. And a deadline being missed means that the system is behind real time by one note at least. And you can react to this. For example, you can skip a little bit and so on. So this example succinctly demonstrates the tools that Lingua Franca provides for writing real-time applications and how you can detect any fault that can occur. For example, in this very time-sensitive rhythm application, if you're late, you can detect that very easily by just adding a deadline handler. And feel free to try this. If you're running a Linux machine Zoom interferes with this a little bit because it uses a lot of CPU. But feel free to try this after the demo. And with that, back to Edward. Thank you.
Thank you, Sarush.